Hello, this is Duncan Foley, and this is part of the lecture program on Lean and Agile Engineering. So what we're going to talk about today is single-minute exchange of dies. Really simply, it's very similar to the Formula One racing team. Imagine that the car comes in and they've got all these pit crew. Their job is to replace all 4 tyres as quickly as possible. If you compare that to your own personal experience, changing a single tyre can take an absolute age, where they've looked at everything, they've got everything prepared, they've got all the tools in the right place, and everything's designed to quickly come off with the minimum force and utmost speed, to the point that now they're changing for tyres to something like 2.4 seconds. In fact, it's interesting to note that it takes longer to say 2.4 seconds than 2.4 seconds. So what they've done is looked at the process, changing the tyres, then they've looked at what can be done prior to the car coming to a stop. Can they get everything that needs to be done ready before it comes in? So it's, you don't want to be stopping and then going to get the tyres. That can be done before, so you get everything ready to do it. So what we're doing is, what do we mean by changeover? So remember, muda, waste. When we're changing over, that red is waste. We're not making profit, so we want to reduce that as much as possible. So the more we can reduce it, the equipment is running, is green, stops, and then the next product B, is produced. But a changeover is only complete when product A finishes and then a machine is making acceptable product Bs. So you have to make one product B, get it checked, and then you can go on to production as well. So so it's the amount of time it takes to change a piece of equipment from producing the last good piece of a production lot to the first good piece of the next one. So when is a change complete? So we said it's running for product A, downtime, mudder, waste, costing you money. So we need to reduce it, and then running part B. So quick changeovers reduce lead time, increase overall velocity. Machines only create value when they are running and not sitting idle. That's obvious. So why do quick times reduce lot sizes? So one of the things that does happen in the industry, if it takes so long to change from part A to part B, you make more part A to justify that changeover. You know, it's going to take 3 hours to change to part B. Let's make more of A and more of B to justify that changeover, and what you get is more inventory. But we know that inventory hides the true issues. And the true issue here is it's taking too long to change over. So I have it reducing the changeovers reduces lot sizes. When lot sizes are reduced, the customer's lead time is reduced. So if you're customer B or customer C, you can change, the changeovers get reduced, so when customer C gets the product, it's so much sooner, because prior to that, you just make a large amount of product A and then change over. It's not worth the time to change over and start making B currently, because it takes so long to change over. Reduce that time and you can change to B to C. It's neither in or there. It doesn't take long to change over, so might as well change over and make customer C happy. This is because most of the lead time is in the waiting. Fast changeovers greatly reduce the need for inventory and inventory buffers. So I recommend you do now, if you've got access to the Gemba Academy videos, go and look at the quick changeover single minute changeover dies overview. They have an excellent website and DVDs and stuff. Improvements on time delivery. Removing the non-value added time results in the customers getting their product sooner. So how can we do that? Separate internal from external setup operations and convert internal to external setup. So what we're saying is internal and external. What we mean is when the machine stops after producing A, to when it's that downtime, we need to reduce that time. Is there anything that we're currently doing when the machine stops that we could have done while the machine was working? So the guys on the Formula One racing, they'll get the tyres out. Yeah, they'll get the tyres out from stock. They'll probably have them still in the blankets, but they'll stand on both sides of where the car's going to be positioned. Yeah, so they're ready, but they've got the tyres out, so that internal and external, they're ready. Is there anything we can do prior to stopping the production of A? And then, so, and if find out if what we do need to prepare before production stops is, and then look at what we're doing from stopping production. Is there anything we could have done beforehand to reduce that time? Standardized functions and shapes, and not shapes, sorry. Use functional clamps. We'll have a look at some of these examples in jigs. Adopt parallel operations. Things can be done at the same time. Eliminate adjustments. You don't want to be tweaking anything, as you know, fine tuning and stuff like that. That takes time. And mechanization where possible. So where does all this come from? Well, Shingo was a gentleman, I think it was Toyota, who they asked him to look at a production of their plant, and they were told, his analysis showed that it was taking nearly a day to change over from one product to another with the press machine. He looked at what could be done prior to it by redesigning the press so it just went in and it didn't take as long to put the press in and set it and get it working, and he got it down to minutes. Think of it, you know, a days to minutes. If you look at other products, you know, a company who makes tea bags makes nearly 30 million tea bags a day. If you can reduce that by 1 second, that's a massive changeover. So what he did is a system designed to radically reduce the amount of time to perform a changeover or a setup. Simple ideas. If you think about a bolt, when you tighten a bolt, you turn it. It's only the last quarter or sixth of a turn that actually tightens anything. All the other is just spinning the bolt around. So by doing interrupt screws or interrupt threads, you can drop it straight in and just do that quick turn, and it takes seconds. Whereas you could be losing a minute undoing tightening bolts and stuff. On a similar vein, nut bolt and washers and stuff, if you, instead of having a full washer, you have a C washer. So when you undo the bolt, it only takes a little turn to undo it, and then you can slide the C washer off, and the bolt will clear the hole. Just little things like that. And so very similar to what number 2 is there, a C washer, and the pear-shaped number 3 slots. Very similar to what you find when you buy something from like IKEA. Yeah. Things like number 6, wing nuts. All you do is just turn the wing nut a couple of times, then it'll come out, rather than spending ages undoing it. Cam methods, snap methods. All of these you've probably come across, or when you look at them, it's reasonably obvious. The slag clamp used a lot in industry, really quick and easy to do, but it saves you time. So when you're designing machinery and stuff, or of jigs and fixtures and stuff, this can knock minutes off your time. Again, take the opportunity to go and look at the next in the line of the Gemba Academy on quick changeover and single minute exchange of dies video. Improvements with successive runs. So it takes 60 minutes to change over. So you set up 60 minutes, and because it's taking 60 minutes, you really need to be running quite a long time to justify that setup. So you run the machine for 360 minutes and you get a certain number of products, and you're running it for 360 minutes just to offset the time it takes to set up. Could we reduce that? you know, we're making one customer happy. Could we reduce it to 120 possibly? Yeah. Still 60 minutes to change over. We can't satisfy 3 customers. So if you look at row 2, still 60-minute changeover. Let's cost effectively, yeah, we can spend 60 minutes setting up and 120 minutes of product, and that 120 minutes would just about pay for the 60 minutes setup. But you're still not making many people happy or many clients happy. If we can reduce that setup time from 60 to 30, then we get in there. We nearly get in there. In fact, but if we can reduce it to 12-minute setup times, we only have to really, in this scenario, we only have to really run the machinery for 72 minutes that pay off that 12-minute setup time. And that means that we can actually make 5 customers happy. You know, if they only want one of these products and stuff, so customer, you know, A, B, C, D, E, you know, it'll get them the product, whereas it could take, you know, days before customer E will get one of their products and stuff. So if you're looking for the, you know, say the first one is red, blue, green, yellow, you know what I mean? If you're waiting for a yellow one of these products, you could be waiting for days with the current situation of 60-minute changeover. Like I say, you'd run in for 360 minutes just to pay off the 60-minute setup time. So by spending a lot of companies spend a lot of time in reducing the time to make the product, and not enough time thinking about the changeovers as well. So having thought about that, have a think about where you've seen single-minute exchange of dies in your experience around you. It will be there. Like I say, IKEA is a great example of you know, where they've used cam type little nuts plug that you plug in, and then you turn it like quarter of a turn, and it tightens the whole shelving unit together and stuff like that, rather than having nut bolt and washer and stuff. Have a look at the new topics yourself. Look at Six Sigma as well. It's in the same field of lean and agile, and maybe get into groups and stuff and discuss it. Hopefully that was useful to you guys. Thanks a lot for listening.